Okay, welcome back. Now I'm going to do a demo I call primary colors. I'm going to explain the difference between additive and subtractive colors, talk about it a little bit, and then I'm going to be turning off the lights and showing you the demo. So we have primary colors here. The additive colors, the primary colors are blue, green, and red. And you can see here in the Venn diagram that we have here, when we combine green and red here, we get yellow. So I put here, this is green plus red, and this is yellow. And then if we combine blue and green, we get a color called cyan, right? And if we combine red and blue, we get a color called magenta. And if we combine all three of them, blue and red and green, we get white color, which is a combination of all the colors. So these are known as the additive primary colors, and this is how humans see color. By combining, we have color rods in our eyes that are sensitive to different wavelengths. They are sensitive to a range of wavelengths, but primarily we can say they peak at these wavelengths of green, red, and blue. Okay, so they're sensitive to primarily those colors. So by combining these colors, we can make these other colors known as the subtractive primary, the subtractive primary colors, or they're also known as complementary colors. And by adding all three of them, we get white light. So now let's explain here the subtractive primary colors, also known as the complementary. They're complementary to each other. So we can add here complementary, okay? And I'll explain here why we mean they're subtractive and why they're complementary. So now when I combine cyan and yellow, so I'm combining basically cyan and yellow, right? These two, cyan and yellow, and I'm getting green. So you can kind of think of it as I'm combining yellow and this one, and I'm getting this one, green, right? And then if I combine cyan and magenta, so then I'm combining this one and this one. If I combine cyan and magenta, then I'm going to get blue. So you can see here cyan and magenta, and I get blue. And if I combine magenta and yellow, so then I would be combining this one with this one, then I would be getting red. So magenta and yellow, and I'll get red. And if I combine all three of them, I get black, right? So this is basically how ink color works on the printer, right? Because for ink color, we want to be able to make black, right? So how do we make black? When we add all the three complementary or subtractive primary colors, when we add all of them, we get black ink. So that's how we print black. And if we want red, we can combine just the magenta and the yellow. If we want to get green, we can combine the cyan and the yellow. And if we want blue, we can combine magenta and the cyan. And we can make a nice colored printer to make the different primary colors. So basically, by adding the subtractive colors, we are making the additive primary colors, green, red, and ink. So that's why these are used in printers, okay? So then let me explain to you why they're called also complementary or subtractive. So when I subtract, see, each of these has a complementary. So green is complementary to magenta, and yellow is complementary to blue, right? And cyan is complementary to red. So these red, blue, and green are the primary additive colors, and each of them has a complementary color from one of these three. So we can say for green, which of these colors is its complementary color? For green, it's magenta. So that explains why the term complementary. For blue, which one is its complementary color? For blue, its complementary is yellow. And for red, its complementary is cyan. Okay, the other reason it's called subtractive is that when I subtract magenta from white light, I'm going to end up getting green. So let me show you that it's kind of almost like an equation. So that's why they're called subtractive. If I subtract magenta from white light, right? What is white light? It's the combination of all three colors, right? So subtract, so white minus magenta. Okay, so what is white light? Blue plus red plus green. Blue plus red plus green. If you subtract from that magenta, well, what is magenta? Blue plus red, right? Blue plus red. If you subtract that, what do you get? Blue plus red cancels the blue plus red, and then you get green. You see? So if you subtract magenta from white light, what do you get? Green. So magenta is the complementary color of green. You see, that's why it's called complementary. It's subtractive because you're subtracting these from white light, right? And if you subtract yellow from white light, okay, what do you get? Let's put it here on the side. White minus yellow. Okay, so you're going to get blue plus red plus green. And then yellow is green plus red. Green plus red. And then you subtract red, red cancel, green, green cancel, and then you get blue. Right? So if you subtract yellow from white, you get blue. And therefore yellow is the complementary color of blue. And then finally cyan. If you subtract cyan from white light, okay, so you get here blue plus red plus green minus cyan, and then cyan was, let's see here, cyan was blue plus green, right? Blue plus green, then blue plus green cancel, and then you get red. See? So now you can see why the term complementary and why the term subtractive colors. So subtractive colors are very, very useful because by adding them, you get the primary colors of green, red, and blue. Now, black, why do we get black? Well, by subtracting all three of them, right, from white, what are we going to get? White minus magenta is green, right? And then we have here white minus yellow is blue. And then we have here white minus cyan is red, right? So we can see that these are all the complementary colors from white. By subtracting them, we get the primary additive colors. So now what's happening here in the middle where we're getting black? How are we making black colored ink? Well, we're combining yellow and cyan and magenta, equal amounts of yellow and cyan and magenta. So we're combining yellow plus cyan plus magenta, and we're getting black. Well, why is that? We can see this as an equation, right? Why is that? Well, yellow, you can see here, yellow is white minus blue, right? So yellow, you can almost treat this as an equation. White minus blue is yellow. White minus blue. And then cyan is white minus red. White minus red is cyan. White minus red. And then you can see here magenta is white minus green. White minus green is magenta. So we have here white minus green. Okay, I want to show you that this gives you black. Well, you have here white, white, white. So this, we pretty much have just white. And then minus, so we have blue, red, and green. Minus blue plus red plus green. So you have you're subtracting black, you're subtracting, so you're subtracting blue, you're subtracting red, and you're subtracting green. Blue, red, and green, you're subtracting it from white. Well, what is white? White is blue plus red plus green, and you're subtracting that blue plus red plus green. So basically you're subtracting all the combination of all the subtractive colors from white, and then you're getting black. Okay, so this B, don't confuse it with black. This B is blue. By adding all the subtractive colors together, it gives you the effect of subtracting blue, red, and green from white, which white is blue, red, and green, and then you get black. Okay, so now I'm going to show you a demo. I'm going to turn off the lights and bring this instrument here. Okay, so now you can see this instrument here. I'm going to turn on the green light. So this is green right here. You can see it. Okay. So then I'm also going to now turn on the red. Okay, so you can see here, this is green. It's kind of a different hue of green. Okay, this is red. And then the combination of them should give you what? Right here. Okay. It should give you yellow, right? You can see that it is giving you yellow. So red and green gives you yellow right here. Now if I turn off the red and I turn on the blue. Okay, so now this is blue and this is green, right? And then they give you cyan. So this is cyan right here. Blue, green, and then the combination of blue and green is cyan, right? Okay, so now I'm going to have red, and I'm going to have blue, and red and blue gives you magenta. Okay, so red and blue gives you magenta. So those are all the different combinations. Now let's turn on all three of them. Right, so you have here green, red, and blue. Combination of all three is right here in the middle, is giving us white. Red, blue, green, and then the middle portion here is white. So now let's do the subtractive colors and add those and see what we get. So we have here the cyan, right? This is a particular shade of a particular hue of cyan. So of course the experiment depends on what hue or shade of cyan or magenta or yellow that you use. The best, in order to get the best results, you have to use a particular wavelength of each one in order to combine them to get the best results. So, and then this is the magenta, right? A particular hue of magenta. Then I have here the yellow. Okay, the yellow and the magenta, and I'm supposed to be getting a red. So I don't get a specific really red, deep red color, but I do get like a lighter red color, kind of looking almost like on the verge of being yellow or orange, right? More like orange, but you can kind of see the idea does work, that you're adding the two subtractive colors, yellow and magenta, and you're getting a particular hue or shade of red, right? So now let's turn off the magenta. Now let's combine the yellow and the cyan, right? And then if you combine the yellow and the cyan, you're supposed to be getting green. Again, it's not a perfect deep green color, but you can see that does have a hue of green to it. Yellow and cyan, and then you have a green. Now I'm going to turn off the yellow, and then combine the magenta and the cyan, and I'm supposed to be getting blue. Again, I'm getting more purple color, cyan and magenta, and I'm getting more purplish, but you can kind of see that I'm getting a color in the hue or shade of blue, right? So this is the good demonstration showing these mixing of the subtractive colors. Now if I add all three of them, right, I'm supposed to be getting inside in the middle black, perfectly black. So this illustrates it doesn't quite work very well because I don't have the exact wavelength of all three of these. But so you can see the idea of this demonstration. You can try at home different colors, different hue of different cyan, magenta, and yellow, and combine them to see what kind of the colors you get. Try adding different colors of the additive primary and also the subtractive primary numbers and see what colors, what mixtures you get and which ones work the best. Okay? Thank you very much.